So now let's talk about nature of roots. Again, repeating the same things that we did in the last lecture. How can we determine what are our roots type of? So our roots can either be real and distinct when we find out our discriminant, which is b square minus 4ac. If it is greater than 0, then we say we have two real and distinct roots. If it is equal to 0, we say two real and equal roots, and we say that our equation is a perfect square. And if it is less than 0, we say we have two complex roots. Now, when we have two real and distinct roots, that means a discriminant value, that means the value which is inside the root, it is positive. And if it is positive, that means that entire term would become irrational because it is not a perfect square, right? So if it is not a perfect square, that means the value would be at a lot of point decimal values, right? That means it is considered to be irrational. So if this is the case, that means we say our quadratic is not a perfect square. And what else can we say? Our roots are conjugate irrationals. What do I mean by conjugate irrational? Because one of the roots that you are going to have, let's say alpha, would be minus b plus root d by 2a. What would be the other root? It would be minus b by 2a minus root d. So whenever you have an irrational term which is in plus and the other term which has minus of that irrational root, that time we say they are conjugate terms. So that is what we are saying here. For this, if it is equal to 0, our quadratic would be a perfect square. That means whatever our quadratic is, we can express it in this format. This would be our show of quadratic equation. Now if delta is less than 0, the equation has complex roots. Now when do we say that we are going to have complex roots? That means our roots are basically going to be conjugate complex numbers. So our roots, inside the root value, we are going to have a negative value. That means we cannot solve that, right? So roots are conjugate complex numbers. Now you will learn more about this when we study the chapter complex numbers. There you will see why we are calling this as conjugate complex numbers. There you will learn how you can solve a negative value as well inside the root. Again, it is going to be an imaginary number, but in imagination you are going to be solving that. So we'll do that in the complex numbers chapter. For the time being, you can remember all these things. Now let's look at this example. If the roots of the equation x square minus 4x plus a square minus 3a is equal to 0 are real and distinct, find all the possible values of a. So they've told us that the roots are real and distinct. If my roots are real and distinct, that means what I can say, my discriminant would be greater than 0. If my discriminant is greater than 0, that means what am I saying is my b square minus 4ac should be greater than 0. So my a is 1 here, my b is minus 4, and this value is my c. So b square minus 4 square minus 4 times of a into c. A is 1 and my c is a square minus 3a. This should be greater than 0. So let us solve it. We are going to get 16 minus 4a square plus 12a greater than 0. So from here what do we have? Minus 4a square plus 12a plus 16 greater than 0. Now as we had studied in functions, if we take minus common from here and if we substitute it, if we multiply it by 0, our sign of inequality would also change. So this would become 4a square minus 12a minus 16. This would be less than 0. I've simply changed the sign and I've changed the inequality as well. So now if I try to solve this, I can take 4 common and remove it. So this would become a square minus 3a minus 4 less than 0. What are the roots of this equation? I can simply see the factors. It is one of them is minus 4 and one of them is going to be plus 1. And as we had studied by in functions how we can find out the range and domain, so from here we can say my A would be belonging from -1 to 4, and I'm keeping them in open brackets. Of course I cannot include them because there is no equality sign here. So for my roots to be real and distinct, my possible values of A lie in this range. So this is how we find out our generally discriminant values. Now talking about nature of roots, again the same things. Now there is another term that you have to study here, that identity. What if I say that my function or my polynomial is an identity? If I'm saying that it is an identity, that means all my constant terms are 0. Whenever I have any quadratic equation, biquadratic, cubic, or any degree polynomial, if I say it is an identity, that means my an is equals to an minus 1 is equals to an minus 2 is equals to up till goes on up till a1 is equals to a0. All these values need to be equal to 0. Then only I can say my quadratic equation is an identity. So that is what has been mentioned here. If this quadratic equation is an identity, then ax square plus bx plus c is valid for all real values of x. That means all values of x would satisfy this equation. Of course, if all my constant terms are 0, it would become 0 is equals to 0. Now whatever be the value of x, the equation would be satisfied, right? And there would be more than 2 real roots. There are going to be infinity roots. The roots are basically going to range from minus infinity to plus infinity. So that is why we say this is the condition for it to be an identity. So keep this thing in mind. Now talking about conversion of equations. Now again, repeating the same thing that we did in the first lecture. What we said was, let's say if I have ax square plus bx plus c is equals to 0, and I have 2 roots here, alpha and beta. So how can I represent my sum of roots? It is minus b by a, and my product of roots becomes c by a. If this is the case, now let's say if quadratic equation has not been given to me, so based on the roots, how am I going to write down my quadratic equation? It can be written in this format: minus s x plus p is equals to 0, or x square minus alpha plus beta x plus alpha into beta is equals to 0. This is how I am going to write down my quadratic equation. So now this is what we are going to use to modify our quadratic equation. Now let's say you are going to be given different roots. Based on that, you have to form your quadratic equation. Let's look at this example. For instance, if the roots of ax square plus bx plus c is alpha and beta, that means this equation has roots alpha and beta. So from here what we can say, simply alpha plus beta would be minus b by a, and alpha into beta would be c by a. Then the equation which has roots 2 alpha and 2 beta is, now how can we find out this equation? This is the equation that we need to find out. I'll also give you the shortcut trick how you can find out this equation. But before that, I have my roots. My roots are 2 alpha and 2 beta. So what is their sum going to be? The sum would be 2 alpha plus 2 beta, and their product would be 2 alpha into 2 beta, which can be written as 4 alpha beta. So if I write down my quadratic equation, it would be x square minus s x plus p is equals to 0. Now if I replace it, x square minus, this becomes, I can take 2 common outside, this would become alpha plus beta x plus p, alpha beta is equals to 0. Now from the first equation, we know alpha plus beta was minus b by a and alpha beta is c by a. So I can simply replace it. This would become x square minus 2 times of minus b by a, this would become plus b by a x plus 4 times of c by a. Now if I convert this equation would transform to ax square plus 2bx plus 4c is equals to 0. So this becomes my equation. Now the shortcut trick of finding out this equation, let's say if you have roots 2 alpha, 2 beta, simply what you can do is, in this equation you can replace your x with x by 2. Since initially you had your roots as alpha, right? Now I'm writing my alpha as 2 alpha. So in my first equation, if my x was, let's say, simply x, I can replace it by x by 2. Now let's say if I say alpha is, I'm replacing it by alpha by 2. Let's say if I replace it by alpha by 2, then my x can simply be replaced by 2x, and I can put it in this equation and get my answer. Now if you try to solve this equation, what are you going to get? Ax square by 4 plus bx by 2 plus c is equals to 0. If I take LCM, again it would become ax square plus 2bx plus 4c is equals to 0. It's the same equation that we are getting. So this was just a shortcut trick for you to find out the equation. Now let us look at this example. They've given us an equation. They've told us what would be the equation if I substitute my roots as alpha plus 2 and beta plus 2. So if I'm replacing my alpha as alpha plus 2, then what would be my x replaced as? It would become x minus 2, the opposite of my roots. So it would become x minus 2. Simply in this equation, I replace x as x minus 2 and I get this answer. If let's say the shortcut trick is not very comfortable for you, simply what you can do is use this entire format that we just studied, find out the sum, find out the product, write down the equation, and then replace your values of alpha plus beta and alpha beta. Then also you can get the equation. So this was a shortcut trick for you to find out your roots. Now talking about common roots. Whenever we have two different quadratic equations, they can have roots common between them, right? So what are the conditions on which the roots can be common? Now let's say there are two equations, a1x square plus b1x plus c1 is equals to 0. My other equation is a2x square plus b2x plus c2 is equals to 0. Now what would be my condition for common roots? Let's say I have one common root among these two equations. So let's say this has roots alpha and beta, and this equation has roots alpha and gamma. So first of all, what I can say is my roots are going to satisfy my equation. So it would be a1 alpha square plus b1 alpha plus c1 is equals to 0. Also, it would be a2 alpha square plus b2 alpha plus c1 is equals to 0. Alpha would satisfy both these equations. Also in beta and gamma would also satisfy both these equations. For the time being, I'm just writing it down as alpha. Now, when we try to equate these two equations or find out their ratio, the condition that we find out for one common root is this: c1a2 minus c2a1 whole square is equals to b1c2 minus b2c1 a1b2 minus a2b1. So you must remember this condition. Based on this condition, you can find out your common root. So if you remember this condition, it would be easier for you to find out the relation between these two quadratic equations, and then you can find out your whatever unknown variables have been given to you in the question, right? So this is for the condition of finding out one common root. Now let's say if I have two common roots. If I have two common roots, that means both my roots are same. That means both my equations are going to be similar. Either they are in proportional values or they are same. So what I can say is a1 by a2 would be equal to b1 by b2 is equals to c1 by c2, as it has been shown here. So that means my first equation and my second equation, they are basically in proportion. They are going to be in same proportion if I have both common roots. So keep this thing in mind, keep this condition in mind as well for two common roots. Now, to give you a simple step-by-step formula of finding out common roots. To find common roots between two quadratic equations, use the following steps. Assume one of the roots, say alpha, is common between two equations. Substitute alpha in both equations and solve for unknown coefficients. Compare the resulting coefficients to find out the value of common root. Now this is when I am trying to find out one common root. There are two ways. Either you can use this condition if let's say you do not remember this condition during the examination time. However, it is recommended that you remember this and use this in the examination so that you can find out your common roots easily. If not, you can simply substitute the common root in both the equations and then try to compare and find out your value. So that is what you can do. So let me show you an example of comparing and substituting one common root. X square plus bx plus 1 and biquadratic have one root in common. So let me assume alpha is the common root in both the equations. If alpha is the common root, it would satisfy both the equations. So one equation would become alpha to the power 4 plus b alpha cube plus alpha square plus alpha minus 2 is equals to 0, and the other equation would be alpha square plus b alpha plus 1 is equals to 0. Now to find out my common root, what is the main problem in these two equations? I can see that alpha to the power 4 and alpha cube are the problems here. So I need to remove them. How am I going to remove them? My second equation, which is a quadratic equation, I'm going to multiply it by alpha to the power 2. If I multiply it by alpha square on both sides, so in one side I have 0, so it is not going to matter. In other side, if I multiply it by alpha square, I would get some values related to alpha, and then I can cancel it out and then find out my values. So what am I doing is I'm multiplying this equation by alpha square. So if I multiply it, what would my equation transform to? It would become alpha to the power 4 plus b alpha cube plus alpha square is equals to 0. This would become my equation. What was my first equation? Let me write it down again as well. Plus b alpha cube plus alpha square plus alpha minus 2 is equals to 0. This was my first equation. Now what am I going to do is I'm going to subtract these two equations. So if I subtract these two equations, this term would cancel out, this term would cancel out, and this term would also cancel out. If all these terms cancel out, simply what are we left with? Minus alpha plus 2 is equals to 0. So from here we can get alpha is equals to minus 2. So we found out our common root. So my common root alpha is 2. So if my alpha is 2, that means my common root would satisfy my equation. So if this is the case, alpha would simply satisfy this equation. One of the roots is 2. So if I put 2 in this equation, it would become 2 square plus b into 2 plus 1 is equals to 0. From here I would get 4 plus 2b plus 1 is equals to 0. So from here what am I getting? The value of b to be minus 5. B would become minus 5 by 2. This becomes my answer. That was exactly what was asked to us in the question, to find out the value of b. Now let's see if you want to check whether your answer you've gotten is right or not. You can put 2 in the other equation as well. If you put 2 in the other equation, you would also get the same value of b. If you are getting the same value of b, your answer is correct. If not, that means you've got to check again. There might be some mistakes that you have done.